In this video, we're going to talk about the law of sines. So, if we have triangles that are not right triangles, we refer to these as oblique triangles. An oblique triangle will either have three acute angles, like the red triangle in the picture. We call this an acute triangle. Or it'll have one obtuse angle greater than 90 and two acute angles, like the blue triangle in the picture. So to solve an oblique triangle means that we have to find the lengths of all the sides and the measure of all the angles. Well, these aren't right triangles, so we can't use what we have learned so far with right triangle trigonometry. So we will use something called the law of sines. So to solve oblique triangles, we have to have some of the parts, and this gives us four possible cases. So if we have one side and two angles, this case is called angle side angle or side angle angle. And don't get these confused with the postulates and theorems that you studied in high school geometry. It's talking about the same thing, but those were specifically for right triangles. Case number two is two sides and the angle opposite one of them, known as side-side angle. Case three is two sides and the included angle, side angle side. And case four is three sides, side, side, side. So the law of sines is used to solve triangles for which case 1 or 2 holds. Case 3 and 4 are considered when we study the law of cosines, which will be in the next section. So the law of cosine says for a triangle with sides A, B, C and opposite angles A, B, and C respectively, then the proportion sine A over A is equal to sine B over B is equal to sine C over C. And we can use any two of these pairs. So we could say sine of A over A equals sine of B over B. And we would have to have three of these four pieces to find the fourth piece. Or we could say sine of A over A equals sine of C over C. Or we could say sine of B over B equals sine of C over C. So let's take a look at an example utilizing the law of sines. So it says solve the triangle where A equals 40 degrees, C equals 88 degrees, and A equals 6. Okay, so in your homework there'll probably be a picture provided, but it's always helpful just to draw a picture so you get things labeled so you know where everything is. So angle A is 40 degrees, angle C is 88 degrees, and side A is opposite angle A, so there's the 6, and we need to find side B and side C. It wants us to solve the triangle, so let's find all the missing parts. So let's find angle B first. Recall that the three angles of a triangle always add to 180. So we could say 180 minus 40 minus 88 gives us the measure of angle B. So 52 is equal to the measure of angle B. So there's one of our parts. Now let's find either side C or side B, and it doesn't matter which one, we've got to find them both. So we will do sine of A, which is 40 degrees, over side A, which is 6, equals sine of C, which is 88, over side C. Now make sure your calculator is in degrees before you start doing any calculations, but we're going to do a cross product because these are proportions. So this would be 6 times the sine of 88 equals c times the sine of 40. And we will divide by the sine of 40. And so we get c is equal to, now plug that into your calculator, and make sure you read your directions on your homework on what to round to. I'm just going to go ahead and throw this in at 4 decimal places, so 3286. Just to stay as accurate as I can. Okay, now we need to find side B. So I'm going to use sine A over A again. So sine of 40 over 6. And we found B to be 52. So we do the sine of 52 over B. So cross multiply. And we get B times the sine of 40 equals 6 times the sine of 52. We're going to divide by the sine of 40. And we get B equals 7.36. I'm going to go ahead and round this to 2 decimal places for C, so 9.33. So again, make sure you read your directions on your homework. Alright, so when we have two sides and the not included angle, side-side angle, this creates an ambiguous case. So either it's going to result in one triangle, or there's going to be two triangles, two possible triangles, depending on the information, or no triangle at all. So if side A is greater than or equal to side B, then only one triangle can be formed. Okay, so if you have your triangle and A, B, C, so if A is greater than or equal to B, in other words, the length of that side, and my picture doesn't justify what I just said, but then you can only make one triangle in this way. Okay, in this case here we're talking about the perpendicular height h. So if A is less than the height, which is equal to B sine of A, by our right triangle trigonometry, because this is perpendicular, then side A is not sufficiently long to form a triangle. So it would have, if this was side A right here, it actually would be a little bit short. I don't think, let me erase it, yeah. Like that would be a gap. Okay, and again, my picture's not justifying what I'm talking about here, but that's what we're saying. So if A equals H, and that's equal to B sine of A, then side A is just long enough to form a right angle. Okay, so that would form a right triangle. And then the last one, if A is greater than H equals B sine of A, and A is less than B, then two distinct triangles can be formed. So it'll be, one where A is relatively large, and then one where A is pretty small. And we have an example of this in the homework. And again, my pictures are not doing any good, but you'll see from some of the examples that we talk about when this case happens, there's two possibilities that could exist. All right, so let's go ahead and take a look at example 2. So solve the triangle when A equals 9, B equals 4, and A angle A is equal to 60. So you should always draw a picture if one isn't provided, just so you know where everything is. So that this would be A is 9, angle A is 60, B is 4, and we don't know C. Okay, so we could say sine of 60 over 9 equals, and we'll go ahead and find B. So sine of B, since we have B, over 4. Then we would cross multiply. So this would be 9 sine of B equals 4 sine of 60. Then we'll divide by 9. So I get B is equal to 22 point, I'm going to go ahead and say 0.64, rounded into 2 decimal places. Okay, now if I do 180 minus 22.64 minus 60, I'm going to get 97.36, I believe. And now I can do sine of A over A equals sine of C, and I rounded that to 1 decimal place, over C, and we get, kind of ran out of space here, so cross multiply. I'm going to come up here. So this would be C sine of 60 equals 9 sine of 97. I did not give myself enough room. 9 sine of 97.4. And then divide by the sine of 60. And I get C equals 10.31. Alright, example 3, solve the triangle when A is 13, B is 29, and A is 30. So again, draw a picture. Just so you know where everything is. Okay, so this would be the sine of 30 over 13 equals the sine of B over 29. And so I get 13 sine of B equals 29 sine of 30 over 13. So sine of B, and if you enter that in your calculator, you're going to get a domain error. That tells us that a triangle doesn't exist. So we just say there is no triangle. All right, so solve the triangle for example 4 when A is 15, C is 16, and A is 58. Okay, let's first find angle C. So sine of 58 over 15 equals sine of C over C, which is 16. So I get 15 sine of C equals 16 sine of 58. Divide by 15, and sine of C is 0.9046, and so C would be the arc sine. And to keep it exact, I'm going to put the 16 sine of 58 in here. I want it to be as close as possible. So I get C is 64.8. So if we did 180 minus our 64.8 minus our 58, that's going to give us an angle B of 57.2. Now, the way this one is arranged, it is possible to have a second triangle. So this would be, triangle 1. So we could take 180 and subtract our 64.8, and that's going to give us 115.2. And we could do 180 minus 115.2 minus 58, and that gives us enough for another angle, 6.8. So a second triangle could be formed using the same dimensions. So we could do sine of 58 over 15 equals sine of 6.8 over b sub 2, and that gives us a b sub 2 of 2.09. Alright, next we're going to talk about areas of triangles. So the area of a triangle is area equals K, which is equal to 1/2 the base times the height, and that's your general formula for area of a triangle, where A is the area, B is the base, and H is the altitude drawn from the base. So we can put these in terms of sine and say K is equal to 1/2 AB sine of C, or K is equal to 1/2 BC sine of A, or K is equal to 1/2 AC sine of B. So these are just another way of doing the same thing, especially if you don't have the altitude drawn, so you don't have a right triangle that you can work with, or the height. All you have is angles and sides. All right, so example 5, we want to find the area, and we're given AC and angle B. So we're going to want to use this formula here. So K is equal to 1/2 AC sine of B. So K equals 1/2 21 times 42 sine of 47. Okay, so if we put that in our calculator, we get 322.54, rounding to 2 decimal places. Example 6, 2 fire outlook stations are 180 miles apart with Station A directly south of Station B. Both stations spot a fire. The bearing of the fire from Station A is north 55 degrees east, and the bearing from the fire station B is south 60 degrees east. How far to the nearest tenth of a mile is the fire from both lookout stations. All right, so always draw a picture whenever you're doing a word problem. So it says Station A is directly south of Station B. So if this is Station A, then Station B is going to be directly north. And they both spot a fire. So we'll just put a point over here and say fire. And then form a triangle. And it tells us that the two lookout stations are 180 miles apart, so this would be 180. And the bearing for Station A to the fire is 55 degrees. And for Station B is 60 degrees. So they want us to find A and B. Okay, so we can say sine of So first let's find angle C. So that would be 180 minus 55 minus 60, which would be 65 degrees. So this would be 65. And now we can do sine of 65. Since we had side C, we needed that angle, over 180 equals sine of 55 over A. So this would be A sine of 65 equals 180 sine of 55 divided by the sine of 65, and A is going to be 162.7. Okay, now do the same thing for side B. So sine of 65 over 180 is equal to the sine of B over B, and we know B is 60. So this would be B times the sine of 65 equals 180 sine of 60 divided by the sine of 65. So B is equal to 172.0. All right, one more example. Two buildings of equal height are 800 feet apart. An observer on the street between the two buildings measures the angle of elevation to the tops of the building as 26 degrees and 43 degrees. How high to the nearest foot are the two buildings? All right, so draw a picture. I've got two buildings. And they are 800 feet apart. And we'll assume that the buildings are plumb and true. So the distance from the bottom should be the same as the distance from the top. And they are 800 feet apart. Okay, so if there's an observer standing down here somewhere on the street, and this observer is looking up at both of these buildings, we're going to get a shape like this, and these are right triangles. So it said this is 26 degrees and this is 43 degrees. Now if you think back to your high school geometry days, these two lines are going to be parallel to each other, and they're cut by a transversal, and alternate interior angles are congruent. And since we don't know the measure of this side or this side, we're going to have to use the measure of this side. Okay, so that means that this is going to be 43 degrees and this is going to be 26 degrees. So we would use law of sines, sine of 43 over C, so this is going to be C, equals the sine of 111 over 800. Now I didn't tell you where I got 111 from. So this angle right here, because this is a straight line, it's a straight angle, so 26 plus 43 plus this angle, we'll just call it angle A, it's going to equal 180. So the measure of angle A is 111. And that's where I got that from. Okay, so do cross product again, and you're going to get side C is 584 feet. So this is equal to 584.42. And now we need this piece here, the height of the building. So we're going to use the sine of this angle. So sine of 26 is equal to opposites over hypotenuse so if we multiply both sides by 584.42, this should give you the side H, which is 256 feet.